Hi there, I'm Mike, and today we're going to have a look at how you can make the Arduino Nano consume less power. We're going to try and make it consume as little power so that it can even run it on a battery. In our sketch, we're going to have the Arduino turn on the LED for 1 second and then do nothing for 10 seconds, so we have a baseline for comparison. First, you got to choose which pin you want to connect VCC to. If you give the Arduino Nano 5 volts on the V-in pin, it's going to consume about 12.3 milliamps. And if you choose to feed it VCC by the 5 volt pin, it's going to consume about 18.6 milliamps. So just by choosing the right pin, you already save a lot of power. Next off, we're going to remove the LED, because if you want your Arduino to consume as little power as possible, there's no use having an LED just being on to show that the device is powered. Instead of removing the LED itself, we're going to remove the resistor. If you're going to do this with a soldering iron and tweezers, it's much easier to destroy the LED than it is to destroy the resistor. Now, without powering the LED, it only consumes about 10.8 milliamps. That's down from 12.3 already. The next thing you can do is in the code. You can make the Arduino slow down and thereby consuming less power. In the datasheet, you can see which dividers you can use for lower power. Basically, all this does is that it slows down the Arduino by a factor of 2, 4, 8, and so on. So if we're going to slow it down by a factor of 2, the Arduino now runs at half speed. Then just upload the code. Now, by slowing the Arduino down by a factor of 2, meaning that's now going to run on a frequency of 8 MHz instead of 16, it went from 10.8 milliamps without the LED down to 7.5 or 7.2 milliamps. As you can see now, the LED is on for more than the second. It's actually on for 2 seconds. This is because we now slowed down the Arduino. So 1 second delay is now in fact twice as slow, meaning it's a 2 second delay. And this is because everything is now just slower on the Arduino. We can remedy this in code just by dividing the times with a factor of which you're slowing it down with. Let's slow it down further. So now it's going to be at 4 MHz. And upload the code. And now the power consumption is down to about 5.6 milliamps. And we can try to even make it run at 1 MHz. Then it's going to consume about 4.2 milliamps. Okay, for a quick overview, we went from about 18.5 milliamps running on the 5 volt pin, then down to 12.3 running it on the V-in pin, and then by removing the LED, we went down to about 10.8 milliamps. And by slowing down the Arduino, we went down to about 4.2 milliamps. If we check with the datasheet, you can see that we can run the Arduino on a lower voltage as well. This is also going to help reduce the power consumption. And on 4.5 volts, it consumes only 3.5 milliamps. And now we're going to try to make the Arduino consume only about 0.3 milliamps. This is going to be in sleep mode, so we got to do a couple of things. First, upload the code on the screen to your Arduino. Then you need to remove the voltage regulator. And finally, since we removed the voltage regulator, we got to power it using the 5 volt pin. But as you can see, we made it. The Arduino is now consuming only 0.3 milliamps. So now you can even run it off a battery. Be aware that you need to use interrupts to wake up the Arduino again. There's one additional tip that you can use to make the Arduino consume less power. That's having it on for a lesser amount of time. You can do that by removing the boot time of the Arduino. Not everybody is aware, but the Arduino spends 1.5 to 2 seconds just booting up. If you want to learn how to instantly boot your Arduino, we covered it in a previous video. I'll leave a link to it in the description. That's it for now. Hope you enjoyed the video. Please leave a like and you're always welcome to subscribe.